Okay, so in the last video, we left off saying that algebra is like strength training for the brain, and we're moving up on weight today. We're definitely not maxing out though, we're just getting our brain stronger one step at a time or one weight at a time. Okay, so today we are going to focus on multiplying and dividing rational expressions. And actually, multiplying is fairly similar to what we just did in the previous video. And division just has one more layer on top of that, just like building a multi-level house. Okay, so basically, all you do is multiply, and then you simplify. You know, technically you could, I know you guys sometimes like to call it cross multiplying, but it's not called cross multiplying. It's, canceling just a cross. Some of you guys will be like, well, can't I cancel, the 2 and the 12 and make that 1 and 6 and, x squared and x? Yes, but just to keep it uniform in everything that we're doing, I'm just going to multiply straight across and then simplify from there. So this is 12x to the 4th divided by 36x to the 4th. Okay, look at the numbers 12 over 36. Okay, it's just going to simplify to 1/3. And then x to the 4th over x to the 4th cancels out. So that's my final answer. And that's it. That's all you do. Okay? All right, let's do another example though. So let's take a look at example A. So same thing. We're just going to multiply straight across to keep everything the same. So 30 y to the 5th over 40 y to the 6th. Okay, how did I get those numbers to y to the 5th and y to the 6th? Remember that when you multiply powers of the same base, you add the exponents. Okay, and then this is to the first there, so that's how you get 6. Then you reduce the numbers. That's going to be 3 over 4. And then you have a y left over in the denominator. So y to the 6th is bigger than y to the 5th with one y left over, so it stays in the location where the bigger y was. Okay, so let's add on a little bit more weight here. Let's go on. So I know this might look a little intimidating at first, but I know you guys can do this because all it is just factoring and simplifying. So that's going to be our first step, is to factor. Okay, and then basically when you do this, when you multiply across, we're just basically making one big fraction and simplifying. Okay. All right, so I'm going to do some preliminary work. I'm going to factor each one of these separately and then do my work off to the side. Yes, sometimes this requires a little bit more detailed in our work, but that's okay. So I can take out a 3x here, and I'm left with x plus 1. Then I can take out a 4. And I can factor this further. So what two numbers multiply to 9 and add to -6? It's going to be 3 and 3. Negative 3 and 3, sorry. Okay. Then let's go to the upper right one. So there's no GCF. It's in descending order. A is 1. So quick factoring, what two numbers multiply to 3, add to -4. That's going to be -3 and -1. And then the last example, GCF, which we do have 1, we can take out an x, and we're left with x minus 1. So I'm going to take all of that and rewrite it over to the right. So like I said, I know this sometimes creates a little bit more work in the sense of writing things out, but we will be a-okay. All right, so now we're just going to basically look at this as one big fraction. So I can just go straight across. This is one big fraction. And now this looks like exactly what we just did in the other video. So we look for parentheses that are exactly the same. So I can cancel an x minus 3 and x minus 3. Remember that I can only cancel 1 to 1. So I can't cancel this x minus 3 with this one and that one. Okay, if I had another x minus 3 up here, I could, but it has to be 1 to 1. Okay, and then I can also cancel the x minus 1s. So let's just see what that looks like a little cleaned up. Okay, remember that the operation here is multiplication, so do not put a plus sign here or a minus sign. This is multiplication, so I'm just going to put that 4x here, and I'm left with x minus 3. Now, if you got this far, I'd be super excited for you, but we do have one more step to do. So looking outside the parentheses where it's just the GCFs, you have to see if anything else can cancel, which it can. The x's can cancel. So I'm left with 3 times x plus 1 over 4 times x minus 3. You do not need to distribute that 3 through or that 4 through. If you do, it's not wrong. It's just, you're leaving yourself an opportunity to make another mistake. So just leave it as is. So remember, cancel parentheses that are exactly the same, and then check your GCFs at the end, which is right here, to see if anything else can cancel. All right, we're just going to do 2 examples in this one and show you the setup on one of them, and then we'll get into dividing. So this is pretty much all factored for you, which is nice. There is one little catch in here, though. If you notice this set of parentheses right here, that's not in descending order. So if I do some little work off to the side and put that in descending order, remember that the leading coefficient can never be negative. So I'm going to take a negative out. And I'm going to assign it to that negative 6. So I'm going to put negative 6 in parentheses. And then I have y minus 3. Okay, just to make sure that I keep all multiplication there. And since this is all factored for me, I can go ahead and start canceling things. So the y plus 4s are the same. And the y minus 3s are the same. So let's clean this up a little bit. So when you multiply across, that's 4y times y. So that gives me 4y squared. And then in the denominator, I have 5 and negative 6. So that's going to be negative 30. And I'm left with y to the 3rd. Okay. And then from here, you just simplify. So you have negative 2 over 15y. Okay. And that's it. That's all you can do. There's nothing left to the problem. Okay, so just be careful that, technically y minus 3 and 3 minus y are what we call as opposites because they have exactly the opposite signs in front of each term. But just take that negative out and you're left with y minus 3. All right, let's go down to example C. So once again, we've got some preliminary work to do. So that numerator up here is going to be 3 and then x plus 2. And then if I go straight across, that factors to x minus 4 times x plus 3. A was 1. There wasn't a GCF. I didn't need to worry about anything. And then in the denominator, I have dots, so x plus 2, x minus 2. And I saved this one for last just because we do have a little bit of work we need to do beforehand because there is a GCF. So I'm going to take that GCF out. I'm just going to do my work right above it. And then ask yourself, can this factor any further? Which it can. So x plus 3 times x plus 3. So I'm going to go ahead and re-record that down here. Okay, so if you want to color coordinate everything so you know where we got all of it. All right, so now we look and we see what is exactly the same, a 1-to-1 ratio. So the x plus 2's cancel, the x plus 3's cancel, and I'm left with 3 times x minus 4 over 3 times x plus 3, x minus 2. Okay, and then of course, see if you can cancel out those GCFs, which we can in our case. So my final answer is x minus 4 over x plus 3, x minus 2. Okay, You can't cancel those x's. You can't cancel a 4 and a 2. That's it. You're done. Okay. And then in example D, the only thing I want to point out to you guys is that this is w minus 4 over 1. So you would just, do the same thing, multiply across, cancel, and be done with the problem. All right. Last thing we need to talk about in this video is dividing rational expressions. So dividing rational expressions just is one extra layer, one extra floor, and we have to do the good old switch and flip. And then just like before, we're going to simplify. So if you remember, the switch and flip is to switch division to multiplication and then flip the second fraction. And the reason why we say switch and flip first is so that we remember to switch this and flip the second fraction, not the first one. So I just kind of, read left to right. So I go along, I read left to right. Okay, I need to switch the sign and then flip the fraction if I continue left to right. And then this is the same as before. So it's just what we did on the previous pages. We're going to multiply straight across, and technically you could cancel first. So 18 times 4 is 72. And then add those exponents together within each variable. And then we get 162 x to the 7th, and then y to the, y to the 5th. Okay, so now all this is a simplifying problem. So 18 goes into both 72 and 62, or 162. So this gives me 4 over 9. Okay. And then when you divide powers the same base, you subtract the exponents. So you have x to the negative second, y to the second. But remember that you can never leave negative exponents in our answer. So we need to move it over the line and change the sign. Now, just like before when I taught this to you guys, some of you might recognize that, x to the 5th over x to the 7th, that's going to leave x to the 2nd into the denominator. That's fine. I'm just showing you how you do it if you divide powers the same base. So same thing here. We're going to switch and flip. Then we're going to factor. And then we're going to simplify. Okay. So let's go ahead and switch and flip. So I'm going to change that to multiplication and then flip this. Okay. And then hopefully you recognize that we are just doing multiplying now. So we're going to go ahead and start factoring everything. So that first one, there's a GCF of 7x. So I'm going to take out 7x, and I'm left with x minus 1. Then the denominator is the quick factoring because a is 1. Okay. Then make sure you use the fraction that you flipped, and not the original. So x minus 8, x plus 1. And then I just have x plus 1 in the denominator. And then same thing. You just go through and you look to see what's exactly the same. So we have an x plus 1 exactly the same. We have an x minus 1 exactly the same. So we have 7x times x minus 8 all over x plus 3. Okay. And if it helps you, keep the addition and subtraction, its partners in parentheses. So that you don't accidentally cancel like an x here. There's no GCF other than 1 on the outside, so we can't cancel anything else. And that's it. That's the end of our problem. Okay. All right. 2 examples left, and then we're done. Power through. We can do it. All right, so let's take a look at example A. So once again, first thing we're going to do is we're going to switch that operation and then flip the second fraction. But notice that when you flip it, make sure that everything's in descending order. So look right here. That is not in descending order. So I'm going to go ahead and change that before I even try to do any factoring. Okay. All right, let's go ahead and factor. So m plus 2, m minus 2. That would be dots. GCF here, so I can take out a 2m, and I'm left with m plus 2. Then over here, we have to take out a 4, and I'm left with m plus 11. And then since I put this in descending order, I need to make sure I take out that negative and put it in parentheses so I remember that it's a factor with multiplication and not addition or subtraction. So I'm left with m minus 2. Okay. One thing that I used to do when I taught this way back when was when I did take out a GCF, sometimes students would do that in a different color so that they wouldn't forget about them. Sometimes when we do take the GCF out, we forget about them. So if you write them in a different color, so like let's say you're writing in pencil and you use red, then you know that, hey, don't forget about that red. Make sure you include that. All right, so cancel exactly the same. So m plus 2 and minus 2. So I'm left with 4, m plus 11 over negative 6m squared. Okay, and we just have one last step. We do have to look at the GCFs to see if we can cancel anything further, which we can. We can take a 2 out of that. So I'm left with m plus 11 with a negative 2 on the outside over 3m squared. Okay, if you put the negative in front of the whole fraction, that's fine. Just technically, remember, you're not supposed to leave it in the denominator. All right. Last example we're going to do is on the last page. Just like I went over in the multiplication video, we're going to put this over 1. Okay, and then we're going to go ahead and switch and flip. So switch that to multiplication and then flip this fraction to 1 over n minus 3. And then you just do what we did before. So n minus 3 times n minus 3 all over 12n times 1 over n minus 3. And this one's a pretty quick one, actually. Those two cancel, and I'm left with n minus 3 over 12n. Remember that the n's will not cancel, right? Because the n minus 3, they like to stay together. We can't break them up. Okay? So really, the only thing different about this problem is if you don't technically see a denominator, it just means that it's over 1. And then when you flip it, the 1's now in the numerator. Okay? So with multiplying, just go ahead and factor and then start simplifying. With division, you have to switch and flip first. Then you can go ahead and factor and you can start simplifying. Okay? So I hope you feel like your brain's got a good workout today. We're going to keep exercising them and get to that max weight by the end of this unit. Okay? Thanks for watching. Have a good day.